Hello, right, this is the video about radiation. Now, this is one of the things that there's a vast amount of misinformation, a lot of it through ignorance and some through malice on the internet and in adverts, deliberately trying to confuse people and sell things quite often. And in general, it's one of the most misunderstood words there is, I would think. And the thing is, on its own, it's meaningless. It means something spreading from a point or spreading outwards from a source. And unless whatever is being referred to explicitly says what is being radiated, it's meaningless. It's just a word. And most kinds of radiation are completely harmless, or at least in any kind of level that a normal person will be exposed to. As long as they're sensible. Now, for example, one of the commonest things you exposed to, well, you basically can't avoid being exposed to it all the time, is thermal radiation, as something like this measures. Yeah? Everything around you emits radiation. You emit radiation in the infrared type, radiant heat. So it's reading my skin temperature because my skin, the laser, by the way, is purely a targeting thing. It's nothing to do with measurement. It just shows you where you're aiming. And the sensor in it picks up radiation from my hand, thermal radiation, infrared. It's the same thing as the thermal cameras, infrared cameras that you see on police shows, where they can detect body heat, except where these little things just have a single point sensor rather than a full camera has an array of sensors so it can detect a full patterned image. And as you can see, that's detecting body heat. If I point it over at the central heating radiator on the wall, looks like that's idling at the minute. It's only about 40 something C. But everything around you emits infrared radiation, and for the most part it's harmless. Obviously, it can be dangerous, and certain types like fire can be very dangerous. If you get too close, you can get burnt. But that's not the type of radiation that most things on the internet try and panic you about. That's an everyday hazard. Another everyday hazard is sunlight. Too much sunlight can cause sunburn, and because of the UV content of it, can cause skin cancer at high levels. And UV radiation is one of the few things that normal people can expose to that is actually a class of ionising radiation that can damage cells. Basically, anything from visible light through radio waves, anything else you're likely to encounter in the way of electromagnetic radiation has a wavelength too long. Basically, the photon kind of energy cloud size is too big, and it's dissipated over an area of skin, and all you feel is warmth. When you get down to the high end, this increases from right to left for some reason. When you get down to the high end of ultraviolet, UVC and whatever, and you can see that goes straight onto X-rays and then gamma rays, as the wavelength gets shorter and shorter. The photons are basically like bullets in proportion to the size of your cells and can damage the internals of cells. Whereas anything less than that, longer wave ultraviolet and visible light, as I said, the energy is just dissipated over an area and you feel it as heat, obviously. And sunlight is the single most powerful day-to-day source of radiation, electromagnetic again, that you'll ever be exposed to as a normal person. Because sunlight on a clear day has an energy level of around 1,000 watts per square metre. And if actually at the equator, it can reach around 1,500 watts per square metre. Any kind of domestic equipment, radio, Wi-Fi, or anything pales into insignificance in comparison in the energy levels. The absolute legal limit is 10 milliwatts per square centimetre at worst possible exposure. Basically, if you've got your hand wrapped around a transmitter, that is a legal transmitter of any type, the worst possible thing you can get is 1/10 the level of sunlight, which is 100 to 150 milliwatts per square centimetre. Again, most normal things are Wi-Fi example is only 50 milliwatts total output over the whole area of everything it's exposed to. You get more electromagnetic radiation from a light bulb than you do from a Wi-Fi device of any type. On to other things. Another type of radiation which you are exposed to most of the time and can be harmed by: acoustic, sound. When you talk, you hear any sound, that is because of acoustic radiation. Sound spreads from whatever emits it. And at high levels, it can damage your hearing temporarily or permanently. And it can be a gradual degradation if you continue exposed to high levels of sound. You end up with tinnitus or deafness. Again, that's probably one of the greatest hazards to most people. They just don't realise how damaging high levels of sound can be. I mean, anything over 80, 85 decibels, which I'm just about reaching the peak by talking loud here, anything sustained above that can be harmful to your hearing. And in most places, anything above 95, by law, you're obliged to be provided with hearing protection to avoid hearing damage. So again, that's a common one that no one thinks of as harmful radiation, but it's there. Now, on to the types that some of the scam adverts cover. For example, cell phone radiation. Well, that's a cell phone. That's a working mobile phone. It emits light, electromagnetic radiation. It emits sound, if it's playing audio. It emits infrared radiation. It's got a temperature, so a thermometer will read that temperature. And it's on ambient temperature about, but it's emitting infrared radiation to be picked up. And it emits radio waves. Now, the thing is, the output power, the energy level from a cell phone, as I said before, at worst case, from the most powerful transmitter you can legally use, you cannot be exposed to even a tenth the energy of sunlight in equivalent energy from the radio waves. And a cell phone will always try and minimise the transmit power to save battery. They continuously exchange data with the cell tower that they're working with at that instant and tell each other the signal strength they're getting and adjust the power both ways to keep it just adequate for a good signal, but without using any excess power. That's why your phone battery will go flat much quicker if you're in an area with a poor signal, because it's up in the power. It's up in the power to try and maintain the connection, which will flatten the battery a lot quicker. And anything that supposedly protects you from so-called cell phone radiation is either going to have no effect, or if it gets between the phone and the cell base, then the phone and the base are going to start increasing power to compensate for the attenuation caused by whatever the device is or whatever the shield is. And it could well mean you end up getting with higher levels of EM radiation than without it. And it's certainly going to flatten your battery faster if it's between the phone and the base. So they are completely pointless. There is no evidence whatsoever, in fact, that the emissions from a mobile phone or the radio emissions from a mobile phone can cause any harm. Again, too high volume through headphones and you could cause hearing damage, but that's nothing to do with what most of the stuff relates to. Same with Wi-Fi, as I mentioned. Wi-Fi typically runs about 50 milliwatts, a 20th of a watt. And that's radiating in all directions, and the signal strengths are minuscule. The simple thing is, if they work on the same frequency, or the 2.4 gigs band, the classic lower frequency band, is the same frequency as microwave ovens. You don't feel heat by putting your hand near a Wi-Fi unit antenna, whereas anything with a high enough level of radiation, EM radiation, and that type of frequency to cause harm would also cause significant heating. And that's the first effect before it gets seriously damaging, is you feel warmth as you feel from the sun. And there's nothing like that from any kind of Wi-Fi equipment or anything related to it, because the energy levels are just vastly too low. On to other forms. I did mention ionising radiation. Now, that is primarily nuclear radiation, atomic radiation, or X-rays, and as I say, UVC, very high energy ultraviolet, is on that level of well, it's just starting to get to that level of energy where the photons are high enough density, tiny enough and high enough density packets of energy to mess up cells or even atoms as you go higher up. And again, for most things that people encounter day to day, there's, other than UV from sunlight, there's not a lot to worry about. I made this as a teenager, this box. This is my nuclear source, which is actually a switch toggle from a World War II aircraft. So there's nothing illegal about it. It's not particularly powerful in absolute terms. It's just a radium phosphor dot in the end of it. Now this one happens to be, if I get so you can see it, completely encased in a glass bead, which means the particles, the powder, the material in it cannot escape, which means it's safe to handle. Because the problem with radium dial material isn't the radiation from it, because it's too weak to do any harm. The problem is the material itself. If you got the powder from that and inhaled it or ingested it, it could stick in one spot in your body or lung. So the same cells are gotten continuously bombarded by the emissions from it. And over time, that can cause problems. That's why the stuff went out of use, basically, because the workers that were working with it couldn't avoid breathing the dust over time. And they kept getting ill from radiation because of the material they're absorbing. To give you an idea, let me just move it out of the way from here. That's a Geiger counter. It's a real one, not an eBay scam one. And that's now on and just counting background radiation. It's general radiation from everything around us. I was hoping to find some granite to do this video, but because that granite is normally quite radioactive. But I haven't found anything. It doesn't exist around here, really. So you can see that's just clicking occasionally. Just ticking away. It's probably good, I don't know, 30, 60 counts a minute. It's not enough to give any visible reading. This is completely random, of course. That's one thing with radiation, it is random. Now, if I hold it over this in comparison, putting that straight at the sensor, and you see that's off the scale at that distance, where it's the majority of the emissions from that are going straight into the sensor, the Geiger tube in there. So you can see it's relatively powerful, but as I say, that's not powerful to do any harm. You know, it might do if you actually kind of stuck it on your skin somewhere for weeks or months, but at any kind of distance, it's harmless. And a few other examples. This is a gas mantle from an old style gas lamp, probably 1930s, 1950s or something like that, I guess, I don't know. And there's quite a few of these still about because they used to be replaced regularly. The thing is, the originals use a thorium compound. You hear this thing's getting excited already, just moving near it. A thorium compound, which is what allows them to emit the kind of ultra white light when they're heated by the gas flame. And thorium, tends to be radioactive. And you can see it's not anything like as strong like that as the little radium bead, but there's only a tiny area of that whole thing over the centre. The sensor holes, the sensor's only maybe a centimetre diameter, end of the Geiger tube. So overall, the emissions from that are probably about the same as that bead. And there are other things. If I've not lost them. Oh, there we go. Again, these are old watch dials from watches that used radium phosphor fluorescence. Yeah, they're not fluorescent anymore. They're not glow anymore because for the same reason as the bead, because the actual phosphor is broken down over time by the proximity of the radium, the level of radiation it's put up with. So it decays and stops emitting any light. However, the half-life of the radium is about 1,300 years, I think, for 1,300, 1,500 years. So that doesn't change much since these were made. I mean, even if they're 100 years old, it's still 99% or whatever of the strength it was before when it was processed. You can see that's not quite an emission on it. Now, these are staying sealed in the bags because, as I say, it's the powder. If the phosphor material, which you can see it's degrading slightly, it has started to peel in one or two places. You can see little white patches where the phosphor paste, especially in that 3, for example, there's some transparent bits. It has degraded and some of it could have come loose. And it's the powder that is rather nasty if it's inhaled. So they stay in the bags. I mean, that's not quite as powerful. I think that's only got dots. As you can see, the characters are metallic. I think it's just got tiny dots around the thing. It's still not insignificant. It's a lot more than background. But as I say, the actual level of radiation for these, if you've got a watch that uses this, as long as it's intact, the crystal's intact, the case is sealed, there's nothing to worry about. The general advice is don't mess with it. It's fine. You will not be harmed by having a radioactive watch dial and this type of thing. As long as you don't take it apart and start breathing the dust or breaking it up. Anyway, I think that's... Oh yes, that's just another oddity. This is a modern radioactive glow. I'll have to turn the lights out for you to see this. It's not very bright, but it does glow. That's a tritium tube. It's a little glass tube set in the plastic that's lined with phosphor and full of tritium gas. And the tritium is continuously breaking down. It's got a relatively short half-life of only a few years and emitting, I think it's alpha radiation, which is heavy particles which hit the phosphor and excite that to emit light. And you can see it's lit up all over. I'll turn the illumination back on. The thing is, alpha particles have next to no penetrating power. They're too big. They are, I think is it helium nuclei, in effect. So even a sheet of paper or something like that will stop them. The combination of the glass and the plastic this is cased in mean there are absolutely zero emissions. There's nothing more from that than there is if it's just picking up background radiation. So that's another type. It's tritium used on some things for like in some kind of compound or micro. I don't know exactly how they work it, in fact, because tritium is a gas. It's an isotope of hydrogen. I have no idea how they actually work it on coatings or paints or whatever. It could be kind of micro-encapsulated. But it's used on such things as, I believe, gun sights and stuff to make them glow in the dark for a long time without needing daylight to refresh them like fluorescent paint type of materials do. Anyway, that's another just an oddity. and I hope this has been of some interest. Oh, by the way, this is something I was given by one of my older brother's friends as a teenager. He went on a tour of one of the nuclear power sites, because he was interested in electronics as well. This was in a scrap bin, and he scrounged it and gave it to me. It just needed a new battery. It's had a reach. I can't remember if it had a single-use battery in it, but it's 1950s vintage originally. And other than the battery, it's all original. There's actually supposed to be a filter plate on there, a sliding filter, to be able to block alpha or block low energy radiation. I kind of lashed something up with a bit of circuit board when I got it. But that's the tape that held it on disintegrating. The slide piece I made's fallen out. But the detector tube and its protective mesh is untouched. Everything's original inside that. So other than the battery, it's pretty much as it was 50 years ago. So you can see the make in there. Berthold Rato F, which occasionally appear on eBay in probably better condition than this one. To a scrap bin. Anyway, it still works. Anyway, okay, thanks for watching. I hope that was interesting. And please like and please subscribe to the channel if you like to see more content. Okay, thanks. Bye. Okay, there's a couple of bits I meant to cover that I omitted in the main video and distracted myself. One is, you've probably heard that lead blocks radiation. Well, it does in about the same way that tinted or smoked glass blocks sunlight. I showed earlier how strong that is. That will go to full scale and put it straight over the source. That's lead probably about 0.6 by 8 millimetre. Probably knocks it down to about half strength. Or maybe a third, I don't know. Something like that. It depends exactly how accurate that's positioned over the source, which you can't see now to position. But you can see, despite there being a layer of lead between the source and the Geiger counter, it is still reading quite strongly. And I've got a bit more there. Nice chunk. Put that over as well. And it still reads. Again, weaker again. It is having an effect, obviously. It's attenuating it. As I say, it attenuates it like tinted glass. It weakens it, it does not block it. So anything about lead blocking radiation is misleading. In fact, as I understand it, such as hospital x-ray suites that need to be radiation proof to prevent background radiation affecting equipment, actually just use thick concrete, a couple of foot of concrete, rather than particularly lead walls or anything like that. They might use other heavy compounds as well. I think barium's pretty good. But a couple of foot of concrete will have a lot more attenuating effect on radiation or gamma radiation or anything like that than x-rays, than a bit of lead like this. That's one point. The other thing is, this is, as I mentioned, a real, very old, but real Geiger tube type Geiger counter. There are lots and lots of things advertised on eBay as Geiger counters. Some of them are ex-equipment, ex-military research gear. There are also kits you can buy that have a proper Geiger tube in them, a Geiger motor tube, a high voltage source, or whatever, and will detect ionising radiation the same way this will. Depending on the tube type and sensitivity, some will only detect gamma radiation or similar, and others may detect alpha radiation, which is a tube that's got a very, very thin window, because I say just about anything blocks alpha radiation. But unfortunately, percentage-wise, those are few and far between. The vast quantity of eBay listings for so-called Geiger counters are basically electric field detectors or similar. They'll read anything but ionising radiation. I don't know if it's or how much of it is ignorance on the behalf of the advertisers, because lots of the advertisers, stuff like that, sell household goods and clothes and everything, and it's just one of the items they sell, and they don't probably know what they're selling exactly, or how much of it is deliberate deception to try and get people to buy things that people that are worried about radiation to buy something that's going to read everywhere they go, and just frighten them more for no good reason. But just if you look at Geiger counters on eBay or any other site like that, I don't know about Amazon, I've not looked on there, but any like AliExpress or anything like that, be very, very careful what you're looking at if you want to buy a Geiger counter, because a lot of them are not actual nuclear radiation detecting devices, and that's what a Geiger counter is by definition. Okay, anyway, that's the footnotes, and hopefully I've not forgotten anything else. Okay, thanks for watching. Bye.